Binti Fazil with metric number 313015. Today I will explain question 1A. For question 1A, step 1, find the first derivative of the function. The first derivative will help us determine whether the function is increasing or decreasing. Create a sign diagram for f prime x to determine the interval of increasing or decreasing behavior. We will test the interval negative infinity 1, 1, 2, and 2 infinity. For x less than 1, the test point will be 0. So f prime x will be positive 12. So this means that this interval is increasing. For interval 1, 2, the test point will be 1.5. So f prime x will be negative 1.5. This means that this interval is decreasing. For x more than 2, the test point will be 3. So f prime x will be positive 12. So this means that this interval is increasing. For 1B1 Roman, the total revenue function RQ is divided by multiplying the price PQ by quantity Q. For 1B2 Roman, to determine the concavity of revenue function, we need to find the second derivative of RQ with respect to Q. And since the second derivative is negative, the revenue function is concave downward. For Roman 3, to find the output level at which total revenue is maximized, we set the first derivative R prime Q equal to 0 and solve for Q. Economically, the firm should produce and sell 12.5 units to achieve the highest revenue. This is the point where the firm marginal revenue is 0.
My name is Aqilah binti Zulana, metric number 312865. Now I will explain how to solve question 2 part A. First, we are given the total cost function STC 100 plus 2Q plus 0.1 Q square, where the Q represent the quantity of unit produced. Part 1, we need to calculate the marginal cost. Marginal cost refers to the additional cost of producing one extra unit. To find marginal cost, we take the derivative of total cost respect to the quantity MC equal to DTC divided to the Q. Now, I will differentiate its term in the total cost function. The derivative of 100 is 0 because it is a constant. The derivative of 2Q is 2 and the derivative of 0.1Q square is 0.2Q. After differentiate all the terms, we get the marginal cost function MC equal to 2 plus 0.2Q. So the marginal cost of the company 2 plus 0.2 times the quantity produced. Part 2, we need to determine whether marginal cost is increasing or decreasing. Next, we need to determine whether marginal cost is increasing or decreasing as the production increase. From the marginal cost equation, MC equal to 2 plus 0.2Q, we can see the coefficient of Q is positive, which is 0.2. This means that as quantity produced increase, the marginal cost also increase. So the conclusion, the marginal cost function is MC equal to 2 plus 0.2Q, and the marginal cost is increasing as the production increase. That is how to solve the question 2 part A. Thank you.
My name is Afrina binti Zamri, and my metric number is 312918. Today I would like to explain question 2B. The question is, the price function for a product is given by P equal to 100E power negative 0.05Q, where P is the price per unit and Q is the quantity of output sold. For the first one, find the quantity that maximizes the revenue. First, we need to calculate the total revenue. Total revenue is equal to price times quantity. And we get the answer is total revenue is equal to 100 QE power negative 0.05Q. Then we need to calculate the quantity that maximizes the revenue. We need to calculate the total revenue divide by quantity to get the quantity, and then we get the quantity. The maximize the revenue is 20 unit. The second one, we need to determine the interval where the total revenue is decreasing and increasing. We need to use first derivative order to calculate the interval. First, use first derivative to calculate total revenue divided by quantity equal to 100 minus 5Q power negative 0.05Q to test the interval. The critical point is 20. We need to do the table that shown in the below, and then we get the answer. For the first one, the total revenue is increasing the interval equal to 0.20, and the second, total revenue is decreasing on the interval is 20 to
Question 3. A local manufacturing company aims to maximize its profit. The company's demand function is Q minus 90 plus 2P equals to 0, while its average cost function is AC equals to Q power of 2 minus AQ plus 57 plus 2 over Q. So the first question is we have to find the value of Q for which the profit is maximized. So the first thing that we have to do is express the price P in terms of from the demand function to P equals to 45 minus 0.5Q. After that, we have to find the total revenue. After calculating the total revenue, we have to find the total cost. And then after that, we have to form the profit function. After forming the profit function, we should take the first derivative and simplify it. And finally, we find the critical points by setting the first derivative equals to 0. So our answer will be Q equals to 4 or Q equals to 1. The second question is, using the second order condition, prove that the quantity in I results in maximum profit. So we need to take the second derivative and testing both of the critical points. And our answer, the result in the maximum profit is Q equals to 4.